can we Wile E. Coyote monodepth? So like, can we trick it into thinking there's depth where there actually isn't? Today, I'd like to explore the edge cases of monodepth. So monodepth has so many different possibilities, but there's a lot of times where ambiguities arise. So things like reflections and refractions and pictures within pictures. And there's so many situations where it's really unclear what we mean by depth. Do we mean like the physical depth as in if you threw an object, what it would hit first? Or do we mean the optical depth? Or do we mean some sort of kind of imaginary depth where it's kind of what we, like our headspace projects into the world? So things like photographs are kind of great examples where it's kind of unclear if we want to stop at that photograph or whether we want our 3D information to zoom into that photograph. And that can lead us to some really kind of like unphysical environments. Like photographs can have interlapping depth and the geometry can become much more confusing than would exist in kind of the natural world. So for pictures, there's this really interesting transition where it goes from being completely flat and just like an image on the wall to where it becomes the 3D structure and has that mono depth included. It makes you realize that like the distance you are away actually does impact, and how prominent the image is in your initial image will actually decide whether it kind of recursively goes into that image. So we can start to see some differences between Midas and Zoe depth. So in particular, Midas seems to take a much more conservative approach where it tends to favor flat geometry, whereas Zoe depth tends to be very optimistic in having extra depth information there. So reflectance really gets to the heart of like what is depth in this context. So most monodepth algorithms have some sort of truth set. So it has some sort of information that it considers. So usually the source of this truth depth is something like LiDAR or stereoscopic vision that creates some sort of depth information. So things like perfect mirrors, in a lot of cases, LiDAR and stereoscopic vision will consider those to be actual depth. But there are things like water. Water has a very narrow reflectance gap in terms of light. And so things like LiDAR, they might actually consider water to be opaque. And so in the truth set of like water, that might actually end up being an opaque object and not actually have any sort of reflectance. So by flipping these images upside down, you actually can get to a point where the algorithm is confused. It now thinks that the water is the sky and the sky is the water, which like when I look at it, I kind of am tricked too. So like, it's not that impressive because it's like these algorithms are working about as well as like human brains are. But yeah. So historically, monodepth has had a lot of trouble with upside down images because usually they're taken in such a way that the top of the image is the sky and the bottom is the ground. So there's oftentimes this assumption that the algorithms have that the ground is at the bottom of the image and it just kind of goes from there. And so I wanted to try just a spinning image to see what would happen with that. And as you can see, most of the modern algorithms are much better and they don't seem to have this bias at all. Whereas if you use some of the smaller or more real-time systems are the ones that still have this bias. So it's not really a finished bias, it's just a bias that's kind of relegated to the real time. I was recently visiting Montreal and some of my friends are doing projection art. So they are having a bunch of projections, but they're also using AI art in that. And so I was just kind of curious in terms of projections, with you in my world, whether it'll use the projection or the real image. And so it ends up using kind of a combination of the two. This particular scene seems to favor the real geometry and add a little bit of extra details from the kind of false geometry. This is also probably because this is like a pretty bright scene. So like the projection is like not as clear in this particular image. I also wanted to try some lower quality reflections. So we have a window and then also a puddle. So from the reflection on the window, it can clearly tell that that's a reflection and then it gets that right. Whereas the puddle is such a bad reflection that it just thinks it's the ground. I did an example with refraction and it just ended up being a little bit of a mess. So maybe I need a better example for that. So this hose scene is kind of where I realized that Zoe depth is like almost more magic than like, how does this work? Like you're spreading water is transparent. Like I don't think LiDAR or like very many of the 3D techs would like be able to like, this is like you can't do this with photogrammetry. This is really crazy. I was also just really curious about rainbows. Like, I don't know, maybe rainbows have a depth information. I'm just curious. For digital edits, it's actually really interesting how it gets very reasonable answers. So if you invert the image, it still pretty much gives you the same shape. And then if you do something like an alpha compose, like where you layer two images on top of each other, it gives a pretty reasonable result. So that's all I have for today. Thanks and have a great day.